Okay, so in this problem we have a scatter plot with calcium and mortality per 100,000 people. So describe what we see in this problem. Well, let's talk about strength. Well, it's moderately strong, so I would say it's moderate. It's definitely negative. It appears to be linear. It's going down in kind of a straight trend, and there really don't appear to be too many outliers. You might say that this one over here is an outlier, but I mean it's really not too far out of the trend. So I mean it's subjective. I wouldn't consider that to be an outlier, but I could understand if you did. Um, so that's what we were talking about. So form is linear, strength is moderate, direction is negative, and I would have no outliers. Okay. So we got to write the regression equation from this right here. So let's talk about that. So this is the y-intercept, and this is the slope. So our regression equation would be predicted mortality equals 1,676 minus 3.23 times calcium. So in this model, it looks like as calcium increases, mortality tends to decrease. So it looks like calcium in water appears to be a good thing. So interpret the slope and the y-intercept, okay? So as far as, let's talk about the slope first. So we're going to say the model predicts a decrease of 3.23 deaths per 100,000 adults when calcium increases by 1 part per million. And we should really have an about here. That should be about. Okay, so the model predicts a decrease of about 3.23 deaths per 100,000 adults when calcium increases by parts per million. Yeah, when you look at the graph, don't forget this. This is in per 100,000. You got to have that in your explanation. So what about the y-intercept? Okay, the model predicts 1,676 deaths per 100,000 people when there is no calcium in the water. That's when X is 0. And again, I should have put approximately right there, or about, or something like that. Okay? So that's the slope and y-intercept. Largest residual as negative 349 is for the town of Exeter. Explain what that means. Well, we have a trend that's going here, right? And we got deaths per 100,000, and we got calcium. So we got this residual that is negative 340, about 349. So what does that mean? Well, that means that in actuality we had 349 less deaths per 100,000 people than we predicted. So that's a good thing. Okay, that means less people died, and that's a good thing. Okay, so that's what that means. And then we go to E. The hardness of derbies is 100 parts per million. Let's predict the mortality rate. So we're going to go, this is E. So we're going to do predicted mortality equals 1676 minus 3.23 times 100. And if we do that out, we're going to get 1,353. So the model predicts about 1,353 deaths per 100,000 people when calcium equals 100 parts per million. Okay? Now what is R squared? Okay, 43%. What's R squared all about? Variation. So 43% of the variation in mortality is explained by the linear relationship with calcium. So what does that mean? Well, 43% of the variation is explained by the linear relationship with calcium. That means 57% is due to other factors. Okay, so it's not just how much calcium in the water that's going to determine when people die. I mean, there's obviously other factors there, and that's a reasonable conclusion.